Okay, welcome to Solving Systems Efficiently. Now, in this video, we are only going to talk about what type of system is it, what is the method used to solve it, and what would be our first step. So I'm going to try and cover about 6 to 8 examples, depending on how I feel like, and I would highly encourage you to watch all of these because there's going to be very little math involved, and this is more about the philosophy of solving. And if you hold this philosophy in your mind, solving these systems will become very, very simple. So, in example 1, we have y equals 2/3 x plus 6 and y equals 4x minus 7. And you might notice that both of these are in the form of y equals mx plus b. So, what is this type of problem? Well, since they're both in this, we'd say this. They are both in slope intercept form. They're both in slope intercept form. Well, what's our method? Well, the method is we want to set equal, and I'm only going to write this once, set equal by the transitive property. And I'll just abbreviate that prop. Set equal by the transitive property. And so what's our first step? And by the way, this will be the only time I set this up by the transitive property to show you. What if I said this? What if I called this A, and what if I called y B, and I called this C? And I said, you know what? 2/3 x plus 6 is really equal to y. So all I did was I took this line and I flipped it. But I also know that, y is also equal to 4x minus 7. What are we really saying here? We're saying that A is equal to B is equal to C. Well, then by the transitive property, A must equal C. So look, if this equals this and this equals that, well, then this must equal that. Okay, long story short, here's the key first step. When they're both equal to y, we can just say, you know what? 2/3 x plus 6 is equal to 4x minus 7. Alright, let's move on to our second example. Okay, let's take a look at example 2. We have 3x minus 7 equals 15, and wait a second, this is in the form of ax plus by equals c. So let's say this. We have one equation in standard form. Remember, this is what standard form is. Standard form. And we have this other one where x is by itself. And what I want to say here is just one where the variable, because it really doesn't matter if it's x or y, one where a variable is by itself. Okay, so what's our method here? Well, the key is not so much the standard. Anytime we have one equation where our variable is by itself, our method will always be substitution. Anytime where we have one variable by itself, our method is always, always, always substitution. So what does our first step look like? Well, we take the equation in standard form, and then we take the one where the variable is by itself. And whatever the variable is, we will plug it in. So, in that first equation, we would write 3x minus 7 is equal to 15. And the question is, well, what is x? And we see that x is 12y minus 4. And by the way, guys, the way that you can know, I am so sorry, guys. One little mistake. There should be a minus 7y there, which means there should be a minus 7y there. My apologies. But check it out. If you have, after substitution, you only have one type of variable, see how it's only y's right there? That means that you did your substitution correctly. Alright, let's move on. Okay, here we are in example 3. And notice we have 4x minus 3y equals 12 and 12x minus 8y equals 10. And look, my x's and my y's are all on the same side. This is in the form of ax plus by is equal to c. And basically, guys, this type is they are both in standard. They're both in standard form. Now, when they're both in standard form, our method is elimination. Our method is elimination. And the way that you want to eliminate is you want to find out which one of these has a common factor. So we have our 4x and our 12x and our negative 3 and our negative 8. Now, I apologize for the fire truck. So guys, ask yourself this question. Can you multiply 4 by a number to get to 12? Yes. Can you multiply 3 by a number to get to 8? No, not really. So we want to change 4x. We want to multiply it by some number so we can get some value that can cancel out positive 12x. Well, we want to make that 4x into a negative 12x. So what could we possibly multiply it by? And of course the answer is we're going to multiply it by negative 3. So what is our first step? Well, our first step is to then take that and say, okay, we're going to do negative 3 times that entire first line, that 4x minus 3y equals 12. And that should be a review. Remember, after we multiply by negative 3, we can then eliminate our x's. More on that in the next video. Okay, in example 4, let's talk about the type. Well, I see that right here I have y equals, and we know that this is in the form of y equals mx plus b. So we can say one of our equations is in slope intercept form. One of our equations is in slope intercept form. But here we have x equals. And so here we could say, you know what? One of our equations has a variable by itself. Okay, so if it has a variable by itself, remember that is the key for this type of system. When one has a variable by itself, we can use always substitution. Now, you will recall, we get to choose, in this case, which one we want to plug in. So for example, let me do this one a little bit different this time. If y equals negative 9x plus 12, that's another way of saying that y is negative 9x plus 12. So we can actually rewrite this very first equation as x equals 5 plus 7. And if I were to ask you, well, what is y? You would say that y is negative 9x plus 12. And that's how you would do that very first step there, using substitution. Alright, these are my first 4 examples, and I've just like really broken them down. Let me do just a couple more. I'm just going to kind of ad-lib. I'll move like really quick, and I'll just talk through them. And I would encourage you, please watch these next like 2 to 4 examples, just so you have a fully functioning understanding of how to tackle these. Okay, so let's take a look at example 1. I noticed that both of my equations are in the form of y equals mx plus b. And so, since they are both in slope intercept, man, that's sloppy. Oh well, since they're both in slope intercept, I can just set them equal. 3x minus 4 is equal to negative 1 over 5x plus 8. Bam, there is my first step. Okay, let's talk about example 2. Alright, let's see, I see that 1 has a variable by itself. So you know what? We're just going to take this initial equation, 2x plus 5y equals 9, and we're just going to say, you know what? Let's plug in what y is, and we see that y is 12x minus 7. Okay, and by the way, that was the method called substitution. Okay? Alright, let's go ahead and move on to example 7. Well, how do we start off something like this? Notice they're both in standard form, ax plus by equals c. So I know I want to use elimination. And we ask ourselves, can 8 or 3 be multiplied into a number that will get rid of each other? Not really. But what about negative 6 or 2? AKA, what I'm really saying is like, hey, what would it take to get rid of a negative 6? What is the opposite of negative 6? Well, that's positive 6. So what we're really saying is right here, how could I take a positive 2 times what number and make that equal to a positive 6? And hopefully you're going to say positive 2 times, let's use a different color here, positive 2 times 3. Oh. So what are we really saying? We're going to say, hey, we're going to do 3 times our very first line, 3 times our very first line, 3x plus 2y is equal to 15. Alright, I'm going to do one final example as a setup on the next page. It's kind of like a bonus problem. So please continue. Okay, I'm only showing y'all this example 8 because this is the hardest version of elimination. And it's where, and I say elimination. Why? Because these are both in standard form. Okay, they're both in the form of ax plus by equals c. And the problem here is that 2 and 5 have no factors in common, and negative 7 and 12 have no factors in common. So what do you do in the case like this? Well, you have to pick either your x's or you have to pick your y's, and you have to find their least common multiple. Now, because 2 and 5 are a smaller number, I'm going to choose my x's, and I know that what I want to do is I want to start listing them out. So 2, 4, 6, 8, and 10 are my first 5 factors of 2. Or my first 5 multiples, my apologies. And I know that if I start out with the 5, 10, 15, 20, and 25 are my first 5 factors of 5. Now, if you will recall, what we want to do is find the LCM, the smallest number that they have in common. And so we would say that the LCM is equal to 10. So how does that influence us? Well, that means that we want to multiply both of these equations. I want to multiply 2 by some number that gets me to 10. And so I will multiply by 5. And here, I want to multiply 5 by some number that gets me to 10. And that's going to be 2. But remember, to eliminate, I need a positive and a negative. So let's multiply this one by a negative 2. Now, what is that going to look like? Well, if I do 5 times 2x, I get 10x. If I do 5 times negative 7, I get negative 35y. And if I do 5 times 9, I'll get 45. And here, if I do negative 2 times 5x, I'll get negative 10x. And negative 2 times 12, I'll get negative 24y. And negative 2 times 11, I'll get 22. And basically, remember, the key to elimination, we do this so those cancel. Alright? This is the ultimate video on how you solve systems efficiently, and good luck on these next 8 problems.